Okay, so Unit 5 group quiz. Okay, we're going to go through all 20, I think it's 23 problems, sorry. We'll go all through all 23. These are basically exactly like your test with just barely different numbers, just like we always do. Okay, so to simplify, anytime you have a radical with a negative underneath it, the first thing you have to do is move the I. So this becomes I root 80 plus I root 45. 80 breaks down to be, what is that? 4 times 4 times 5. So you can have 4i radical 5 plus radical 45, you can break it out a 9 and a 5, so you can take out a 3i root 5. The 3i and the 4i are like terms, so you just add them together. That's going to give you an answer of 7i radical 5. Okay, 7i root 5. You do not, by the way, have to put the little 2 in the handle number. That's not a big deal. Simplify. So when you distribute, this distributes to both the negative 2 and the positive 1. So 5 plus 3i minus 2 minus I. Whenever you write these, they do need to be written in what's called standard form. So you want to write them with the numbers first. So the 5 and the 2 combine to give you a 3. Positive 3i minus I gives you plus 2i. So 3 plus 2i. And this is a complex number, so part real, part imaginary, but you always have to write the real portion first. Find the sum. Sum just means add. So basically you can just put a big giant plus sign there. Right? Then add 8i, first let's add the real numbers. So negative 3 positive 2 gives you negative 1. 8i minus 5i gives you plus 3i. So negative 1 plus 3i. Simplify. 2i to the 13th power. So you want to make your I1 a negative sandwich chart. So I1, 2, 3, and 4. I would suggest that you probably write this at the beginning of your test anyways, just on the front. Okay, and then it's I1, a negative sandwich. So you're still going to have a 2, and it's going to be multiplied by I to the 13th. Just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 2 times I is just 2i. For number 5, okay, this says solve. It should be simplify. Okay, distribute this. If you distribute the negative 3i, we get negative 21i. Negative times negative becomes plus 12i squared. The I squared turns into a negative 1, so this becomes a negative 12. And when you write this, your answer does need to be written as a complex number. Okay, so the real portion goes first, negative 12 minus 21i. Okay, so complex numbers have the real portion, then the imaginary part. For number 6, since these are binomials, you have to FOIL. So first times first gives you 8. Outsides is plus 2i. Insides is plus 16i. And last is plus 4i squared. The I squared again goes away, and this becomes a negative. So if you combine the like terms, 8 minus 4 is 4. 2i plus 16i is plus 18i. So 4 plus 18i. And there will be instructions that say on your test to write everything in standard form. Standard form, again, is just the real number and then the imaginary portion. One number should be added to both sides to complete the square. So basically, we want to figure out what goes in that space. Okay, all you have to do is take that middle number, divide by 2, and square it. So negative 6 divided by 2 gives you negative 3. Negative 3 squared means you're going to add 9 to both sides. That's your answer. So what number would have to be added? 9. You do not have to actually solve this at all. Next page on number 8, simplify. Okay, whenever you have a binomial in the denominator, to get rid of that, you have to multiply by the conjugate. Conjugate is going to be 2 minus I. Okay, so 2 minus I. In the numerator, you distribute, so 6 minus 3i. In the denominator, FOIL. First times first gives you 4. Outsides is minus 2i. Insides is plus 2i. And last is negative I squared. The negative and positive 2i's will cancel each other out. Negative I squared turns into a plus 1. So we got 6 minus 3I over 4 plus 1 is 5. Since there's no way that these are going to be able to reduce with anything, you can just leave it just like that. Okay? Or you could write this as a separate fraction, 6 over 5 minus 3I over 5. Either of these answers would be correct. Just make sure you understand how to write either one, because in multiple choice, it could be written either way. Write as a complex number in standard form. So to get this in standard form, you have to multiply by the conjugate. The conjugate here is actually negative 7 plus 4i. You're only changing that middle number. So negative 7 plus 4i. In the numerator, you FOIL. So first times first is negative 21. Outsides is plus 12i. Insides is plus 14i. And last is negative 8i squared. In the denominator, again, FOIL. First times first is a positive 49. Outsides is minus 28i. Insides is plus 28i. And last is negative 16i squared. Simplify, so the I squareds turn into a negative 1. So negative I squared gives you positive 8. This one also turns to positive. Then combine your like terms in the numerator. So negative 21, positive 8 is negative 13. 12i plus 14i is going to give you 26i. So plus 26i. Over, in the denominator, 49 plus 16 is 65. Split this up. Negative 13 over 65 plus 26i over 65. Those do reduce. Okay, 13 goes into both of those, so you should end up with negative 1 over 5 plus 13 goes into the numerator here twice, so 2i over 5. So be careful, because I know 13s aren't exactly a real common multiple that you might have memorized, but that is reduced. That is able to be reduced. Number 10, which one is represented by this point? Okay, so you always go real, then imaginary. So if you moved over 3 real, that's negative 3. Down on the imaginary, down 1, 2, 3, 4, 5. So negative 3 minus 5i. And then make sure you just match that up. So the answer here would be C. I would always write the point and then match it up to the answers, as opposed to just looking at the answers and figuring out which one's correct. It's a little bit easier. What's the next step in completing the square? Okay, this one, what you would actually want to do is get rid of that 3 in front. So if you divide all the parts by 3, you're going to end up with x squared minus 6x equals 2. Okay, that one's going to definitely be a multiple choice, and you're going to have to figure out which step matches the correct next step. It should be to get rid of that number attached to the square. Here, solve for x. Okay, before you can do anything, you have to have everything on the same side. So we're going to have a 2x squared minus 3x and a plus 2 equals 0. Factor if you can. Since there's a number in front, you probably don't want to try to factor this because it would be difficult. You also can't do complete the square because there's an odd number in the middle, so that would be difficult. So here, basically your only option is quadratic formula. So A value is 2, B is negative 3, C is 2. Quadratic formula, hopefully we all have that memorized. It's x equals negative b plus or minus radical b squared minus 4ac all over 2a. If you have a note card, I would recommend writing the quadratic formula on there for sure. Then, if we plug in negative 3 plus or minus radical b squared, so negative 3 squared, minus 4 times an a value of 2 times c value of 2 over 2 times a value of 2. Negative 3 gives you a positive 3 plus or minus radical negative 3 squared is 9. Negative 4 times 2 is negative 16 over 4. That simplifies to be 3 plus or minus radical negative 7 over 4. From the negative 7, you need to take out an I. Sorry. So you should end up with 3 plus or minus I root 7 over 4. 3 plus or minus I root 7 over 4. Any questions so far? Yes. Okay, next page. Starting at number 13, it's simplify. Okay, the 12 and the 3 here are both whole numbers, so you actually want to simplify those first. So I would start by reducing those. 3 and 12 reduce to just be a 4 and a 1 technically in the denominator. So now that that's gone, to get rid of the denominator, you want to rationalize it. So you'd have to multiply it by I root 5. You multiply in both the numerator and the denominator. So across the top, you get 4I radical 5 over, in the denominator, I squared times radical 5 times radical 5 gives you a whole 5. Then the I squared turns into a negative 1, so we're just going to write a negative there. And you'll end up with 4I radical 5 over negative 5. These 5s cannot reduce each other away, because one's underneath the radical and one's a whole number. For 14, simplify. So basically you're going to distribute. Okay, distribute to as many things as you need to. So this is going to leave you with 2 plus 4I. Negative 3 times 5 gives you negative 15. Plus 24I. Distribute again, plus 8I. And a plus 10I squared. Simplify what you can. I squared turns to be a negative 1. Combine your like terms, so combine your numbers. 2 minus 15 minus 10 leaves us with negative 23. Then combine your i's. 4I plus 24I plus 8I gives you plus 36I. And that's the answer. Negative 23 plus 36I. These do need to be written in what's called standard form, so real numbers, then imaginary numbers. For number 15, to rationalize the denominator, you multiply by the conjugate, so that's going to be 9 plus I. Multiply in both the top and the bottom. In the numerator, distribute, so 18 plus 2I. In the denominator, you have to FOIL. First times first gives you 81. Outsides is plus 9I. Insides is minus 9I. And last is negative I squared. Negative I squared is going to turn into be a plus 1. When you combine your like terms, we get 18 plus 2I over, in the denominator, these i's cancel. 81 plus 1 gives you 82. Since these are all even, you do need to break them down, or break it into two fractions. So 18 over 82 plus 2I over 82. The only thing that'll go into both 18 and 82 is going to be 2, so that would give you 9 over 41. Plus, if you reduce the 2 and the 82, we get I over 41. And I would prefer that you write these as two separate fractions, because that's how most of the multiple choice are on your test. Number 16, simplify. These are both the same denominator to start with, so since there's a common denominator, you just add together in the numerator. So 5 plus 7 gives you 12 over 3I. Then reduce what you can. So 12 and 3 reduce to give you a 4. Can't have an I in the denominator, so to rationalize it, multiply it away. If you multiply, we get 4I over I squared. I squared turns into negative 1. And instead of writing 4I over negative 1, you just move the negative to the top, and we got negative 4I. $17 is probably one of the harder ones on this group quiz and on your test tomorrow. This one does take a fair amount of work. Okay, so for this one to start with, when you have something squared, you can introduce a radical. Make sure you put in plus or minus. So that leaves you with x squared minus 6x minus 4 equals plus or minus square root of 144 is 12. So you do have to make two different equations here. Okay, we're going to have x squared minus 6x minus 4 equals the positive 12. And x squared minus 6x minus 4 equals a negative 12. You want everything all on one side to try to factor and solve. So if you move this 12, it's going to leave you with x squared minus 6x. Negative 4 minus 12 gives you minus 16 equals 0. That is factorable. That factors to x minus 8 and x plus 2. Then set each part equal to 0. Change the signs in here, so you're going to get a positive 8 and a negative 2. Those are 2 of your answers. You are not done, though. Okay, that's only 2 of the answers, so you would only get half the credit if you stopped there. For this side, you're going to do the same thing. Move over the 12, so that's going to leave you with x squared minus 6x. Negative 4 plus 12 gives you plus 8 equals 0. That factors to x minus 2 and x minus 4. When you split these, change their signs, so positive 2, positive 4. So you have 4 different answers there: 8, negative 2, positive 2, and positive 4. Okay, last page. On number 18. Okay, 18. You first want to start to see if this is factorable. Okay, so move over the 5. That'd give you x squared minus 8x plus 9 equals 0. Is there anything that multiplies to positive 9 and adds to negative 8? That is not factorable. Okay, so the only thing you could do here is you could do complete the square, or you could do quadratic formula. Complete the square is probably a little bit easier. So I'd move over the 9. That'll leave you with x squared minus 8x. Leave that space equals, if you move the 9, that's negative 9. Again, leave that space. Middle number, divided by 2 and square it. It's going to give you negative 4 squared, so we're going to add 16 to both sides. If you rewrite this as a binomial squared, that's x minus 4 quantity squared equals negative 9. And positive 16 is 7. Square root both sides. Make sure you put in plus or minus. So x minus 4 equals plus or minus radical 7. And to move the 4, you add it. So x equals 4 plus or minus radical 7. Those are 2 different answers. Okay, 4 plus or minus radical 7. That is 2 different answers. Now, there are 2 problems on your test that specifically tell you how you need to solve. Okay, this is one of them. Solve by completing the square. So first you have to create the space. So x squared minus 4x, leave your space, equals negative 11. Middle number divided by 2 and square it. So negative 2 quantity, or excuse me, negative 4 divided by 2 quantity squared. Negative 2 squared means we're going to add 4 to both sides of the equation. If you rewrite this as a binomial squared, we get x minus 2 quantity squared equals negative 7. Radical both sides, so do plus or minus. X minus 2 equals plus or minus. From a negative radical 7, you get I root 7, and then move this 2. So x equals 2 plus or minus I root 7. 2 plus or minus I root 7. Like I said earlier, there's going to be 2 problems on this test. One that you have to solve by completing the square, the other that we're requiring you to solve by quadratic formula. So make sure you follow those directions. Even if you get the right answer, I'm not going to give you the points if you don't follow directions. This one, start by identifying your ABCs. So A is 1, B is 3, C is 1. Remember, you can't identify those ABCs until you have everything on one side of the equation. So quadratic formula is x equals negative b plus or minus root b squared minus 4ac over 2a. If we plug into that, we get negative 3 plus or minus radical 3 squared minus 4 times 1 times 1 over 2 times 1. Leaves you with negative 3 plus or minus 9 minus 4 over 2. And when you simplify that, we get negative 3 plus or minus root 5 over 2. Okay, for number 21, to start with, whenever you have something squared, you want to try to get everything to the other side so you can introduce a radical. So if we divide both sides by -2, divide that away, you get x minus 5 squared equals 12 divided by -2 is -6. Root both sides, make sure you put in plus or minus. So x minus 5 equals plus or minus, you can take out an I root 6. And then to get x by itself, add the 5, so x will equal 5 plus or minus I root 6. If you don't remember the plus or minus, it will be wrong. We can do almost the same thing here. Whenever you have a square, you kind of want to leave that by itself. You could do quadratic formula here, or you can move the 25. That give you 3x squared equals -25. So I moved it to the other side. Then divide away the 3. That'll leave you with x squared equals -25 over 3. Square root both sides. Okay, that's going to leave you with x equals, you still have a plus or minus. Radical -25, we're going to split up this radical over root 3. So that'll break down to give you plus or minus 5i over radical 3. You can't have a radical in the denominator, so to get rid of that, you rationalize it, multiply by root 3 in the numerator and denominator. That's going to leave you with plus or minus 5i root 3 over, you have two pairs, or excuse me, a pair, so you can just take out a whole 3. And then the last one, multiply your numbers, so -7 times 5 gives you -35. Add your exponents, that'll be I to the 7th power. If you go back to your I want a negative sandwich chart, we can count up to 7. So 1, 2, 3, 4, 5, 6, 7. So -35, excuse me, multiplied by -I. If you multiply those together, we're going to end up with a positive 35i. Anyone have questions?